Okay. So we want to find the domain of this function. So we have, a little bit big scale. Okay. So we have f of x square root of x plus 4 plus 6. Now, what's the domain? It consists of all the numbers that we can put in the function and get a reasonable answer, right? And get a real number answer. Okay. So let's discuss this just for a minute. I'm going to pause in a second. Why is it that we can't put just any number into this function? So we have, somebody say you can't put a negative into this thing. Well, there's some truth in that, but when you pick a negative number, so you pick negative 15. Question, is negative 15 in the domain? If it is, then you can write f of negative 15 equals, and just writing that out, and then see if what you get gives you a real number. Okay, so I asked him after a minute or two, you get a real number, or didn't you? In other words, how many got a real number, how many did? A couple of people said they didn't get a real number, nobody else voted, which makes me think maybe there's a problem with putting negative 15 into this. We'll talk about that, okay? And then what do we mean by a real number? Well, let's see, we got this one thing. Well, we got f of negative 15, that means x has been replaced by negative 15. So we do that. Now, by order of operations, the parenthesis, the square root sign acts just like a set of parentheses. You got to do what's inside of here. And you get the square root of negative 11 plus 6. Now, if you put the square root of negative 11 plus 6 into your calculator, would you get a number or would you get an error? Okay, so I asked, if you put this expression into a calculator, would you get a number or would you get an error? And somebody said, well, you get an error, and gave me a good reason, because you can't square root a negative. Okay. Then I asked, why can't you square root a negative? And I didn't want to push too hard because we'd already got a pretty good answer here. Okay. But what does the square root mean? The square root of negative 11 would be a number you could multiply by itself to give you negative 11. How do you know that there's no number which, when we multiply by itself, gives you negative 11? Well, you know that because whatever number you multiply by itself is going to give you a positive. It can't give you a negative. If the number is negative, then it's a negative times a negative. That's going to be positive. It's not going to be negative 11. No way. And if the number you're squaring is positive, well, you're going to get a positive. You're not going to get negative 11. It's really important to understand this. Otherwise, you're just memorizing a rule that you might well forget. Okay. This is fundamental, something you really kind of need to know. Okay, so it's not a real number. Where negative 11 isn't real. And I'm not going to write it out, but the reason is to make sure you kind of maybe make a number. Because there's no number you can multiply by itself to give you a negative. Okay. Okay, so we've established negative 11 is not in the domain. Are there any negative numbers that would be in the domain? Okay. How about four, yeah, or four equals what? Square root of four plus four plus six, which is square root of eight plus six. And well, the square root of eight is between 2 and 3. Why is that? Because the square root of 4 is 2. Sorry, yeah, and the square root of 9 is 3, right? Eight's between 4 and 9. The square root of 4 is 2. Square root of 9 is 3. So the square root of 8 is some real number between 2 and 3. So it's definitely a real number. And that number would then be added to 6. Okay. Well, we're not going to go on trying different numbers, although it's something you should maybe do. Try some positive numbers, try some negative numbers, try to get a feel for why this expression might or might not be real for some numbers, whereas it would be real for others. Okay. Now, key idea here is the square of x plus 4 is real as long as the thing you're taking the square root of isn't negative, which means it's greater than or equal to 0. Now that's an inequality. We get x greater than or equal to -4. So if x is -4, what do we get? Just for the square root, we're going to be able to add 6 to it. That's not a problem. But what's the square root give us? Gives us 0. Because -4 plus 4 is 0. Square root of 0 is 0 because 0 times 0 equals 0. Okay. And for any number bigger than 0, x plus 4 is going to be bigger than 0, and we're going to get the result. Okay. That's something very important to understand. If you've got questions about domain and range, very often they involve square roots. And, you know, for the homework, I think was due today, well, due last night. You would have used that. Okay, so what I'm saying is, and it's what I often see. Most people have been through this assignment where we had to do questions like this and can't do this question. Okay? And the problem is that people have not learned how to use the homework to learn material. Okay? So you really have to do that. And you're going to have to figure that out kind of on your own, but I'll keep giving you pointers. If you got through the homework and can't at least answer some of these questions, then you miss a lot of the point. Okay. And I'm talk about, majority of people, they scores 80% or better on this assignment. How do you make a score 80% or better and then not be able to do a typical problem in class? Well, the reason is, I can only guess. One thing people often do in homework is they sit there with examples in front of them and blindly follow the example without ever actually doing it from their own understanding. Okay? And the other is there are plenty of online resources, and it's possible some people use those as much as I've warned against it. Okay? Don't let online resources do the homework. You can use the online resources to learn the material, give you examples and give you explanations, but put that away before you do the homework. Okay? It's totally fatal. You'll not pass a college level math course if that's your habit, unless your IQ is over about 160. Okay? That's most of you, I know. Okay? So I'm not saying there's anything bad about what you're doing. I'm just saying you decide whether it's bad to do well in the course or to struggle with the course. Okay? And make sure that what you do is consistent with your goals. So again, I'm warning against the kind of learning that people typically do in high school. You get away with something. Okay? You have to engage the material. You have to understand that you're going to come to class, you're going to have a quiz. Now, that's very similar to many of the problems in the homework, okay? So take a lesson. When you do the homework, make sure you are doing the homework, not your textbook author and not some artificial intelligence or somebody who gives you all the answers online. Okay? The goal is not to get the points in the homework, don't count that out. Point is to learn the material well enough to pass tests. And in this course, to learn the material well enough that you can accomplish your ultimate goal, which is to pass pre-calculus with a decent grade. Hopefully a very good grade, okay? So be sure you're doing that. And don't feel bad if you haven't. I mean, yeah, if you want to feel bad, okay, but don't feel bad because I'm telling you, okay? You want to feel bad because, oh man, I'm not on track to pass, okay? Not because I'm judging you or anybody else. And I'm not judging you, I'm just telling you it's the way it is. Okay, so the performance in this problem was pretty bad. Okay, but some people did some things correctly. Like I think I saw this inequality in at least a couple of papers. Then I saw something like x is greater than 2. Well, that's not a solution to the inequality. Excuse me. But if you wrote the inequality, you're 90% of the way there, because it's really easy to solve the inequality. So if you got that far, that's very good. Okay. If you understood there was an inequality involved. Now, if you think that 6 has anything to do with the domain, you're wrong. Okay. But it has everything to do with the range. So what numbers can you get out of the square root of x? Okay, now the range of this function. Yeah, just talk about it formally. Let's see. Square root of x plus 4 can be 0. X is equal to -4. Okay. So square root of x plus 4 can be 0. Make x a little bigger than -4. This will be a little bigger than 0. keep making X bigger, this gets bigger and bigger, okay? And it could be any real number. Now, we can prove that by writing an equation, but, it's probably a good time to do that, okay? Now, get a real number greater than or equal to 6. I'd like to say a lot more, but we're getting to move on. We say the range of X is, 6 to infinity. So I recommend that you review your assignment, review what the text and the videos have told you, try to understand it in a way it's going to work for you when you have a test. Especially tests in your Math 161. Okay? Because sure you're going to see something like this. Now, there are other things about domain and range. We can't talk about them all. But again, approach your homework in such a way you come in and do these things. Okay? To the best you can. I mean, some of the stuff is pretty hard. It's going to go over your head the first time you see it, and then we try to fix it in class. But be as prepared as you can by engaging the material as best you can. That's your path to success. Okay, we took a little more time on that than I really wanted to, but it's kind of worth it. There's a lot that I haven't been able to say. Maybe we'll talk about it a little more next time. I'm gonna take a quick look at our calendar. Yeah, we're gonna have composite functions, so I really need to talk about that. So if this stupid thing would show me a little icon, whether it's recording, I've said this before. This is really getting irritating. Okay. I'm on the verge of saying bad words. Shucks, I just did it. Okay. All right. I think the question we got here is easy, right? be able to write these down pretty quickly. If you understand what we did with function notation. I think it was, about a week ago. And we focused real well. That's not Zoom's fault. I don't know what's the matter with the camera. It'd be nice if it had a fixed focus, so it doesn't. Okay, there you go. Okay, I think y'all did pretty well with this. Didn't get to look at what everybody did. There. Okay, now of course, 5 plus 4 is 9, the square root of 9 is 3, add it to 6, you get 9. You can do that if you want. But really, I'm just interested in the substitution step, okay? Because this is what we're really getting at. Go from here, you can simplify it easily. Okay, now f of a, well, a has replaced x, so replace this by a. And you can't really simplify that. And then you got a plus b to replace x. That gives you the square root of a plus b plus 4 plus 6. You don't know what a and b are, so you can't really simplify that. And f of g would be the square root of b plus 4 plus 6. And then f of g of x would be what? Would be the square root of g of x plus 4 plus 6. Now, if g of x equals x squared, what's the expression for f of g of x? As we've seen, f of g of x literally means this. And that's what? If g of x equals x squared, then that's x squared plus 4. Square root of x squared plus 4 plus 6. Now, people sometimes want to simplify the square root of x squared plus 4 as x plus 2. And that's very, very low. Okay. It doesn't work at all. And we'll see what maybe a little later. But you know, that's incorrect algebra. And it looks like it ought to work. You ought to be able to take the square root of this and the square root of that. It's like a distributive law. But there is no distributive law for square rooting. Okay. So kind of store that idea away. You got to be careful when you do something like that, because it's really easy. Do it because it looks like that ought to be true. But you got to understand that it is. Okay. Okay, so if f of x equals 2 to the x and g of x equals 1 over x, then what is f of g of x? And what is g of f of x? Now, as I did here, your first step ought to be just replacing x here by g of x, right? After you replace it by g of x, then you can look at what g of x is equal to. You replace with that, right? But don't even look at g of x equals x squared. You get this expression f of g of x, look at f of x, it tells you exactly what to do, right? This. In this case, it'll be different. Then you look and say, okay, now we know what g of x is. Yeah, it's x squared, so there it is. Okay? Make sense? Okay, well, excuse me, g of x equals 2 to the x. So g of f of x is going to be 2 raised to the f of x. Very simple. X has been replaced by f of x, so you replace x by f of x. Then f of x equals 1 over x. G of f of x equals 2 raised to the 1 over x. Okay. So it's fairly straightforward. Now I'm going to talk about a little bit about at least the domain of this. Is there a number that you can't put in here for x? Okay, so I just asked the question, is there any x that doesn't give you a real number when you do this? Okay, now, in your homework, the two main cases where a domain is restricted is when you have a square root of a negative or when your denominator is 0, because you can't divide by 0. So if you put in 1 for x, 1 over x would be 1 over 0 would be how many zeros you need to make 1. How many zeros does it take to add up to 1? Well, zeros are never going to add up to anything but 0. I think we said that in here, but it might have been in another class. That's something that's well worth pondering until it's second nature to you. Because like if you did the homework and have a case where the denominator was 0, it could be that what you see when you see an example in the book is just, okay, the denominator can't be 0, okay? Or the book set the denominator equal to 0 in this example, so I better set the denominator equal to 0 in this problem. And without ever understanding why you set the denominator equal to 0. So make sure you ponder, the reason is you can't have 0 in the denominator because you can't make up the numerator by zeros. So a bunch of zeros never will add up to the numerator, okay? There's a rule, you can't divide by 0. That should have been drummed into you a lot better than I think it is in your prerequisite courses, because my pre-calculus students never seem to understand that division by 0 is forbidden. Okay. Okay, that helps. The domain of this would then be any real number could be x except 0, because your g of x function, I did this wrong. I wrote this down wrong. I assume G of X is your two to the X, that's one over X. And I was using G, why should I use F, and F, why should I use G? Write this down the way I should have. Hopefully I didn't confuse anybody. Is okay, F of X. Two to the one over X is right, but have my S and G's back. Well, now, you do G of F of X. Okay, first of all, I would write up here what G of X is. Notice I left myself room unlike before. I wrote it wrong. Okay, G of X is one over X. So G of F of X would be one over F of X. X equals two to the X. So you substitute two to the X for X and you get your function G of F of X. That certainly makes sense. Fairly simple if you understand substitution. But of course, you got to practice and do several before it becomes second nature to you, which it needs to be if you're going to do it under the pressure of the test, right? Okay. And let's try a couple more. F of G of X, what's G of F of X? Okay. Now, what's F of G of X? Well, F of X is 5 times the square root of X minus 2. So X has been replaced by G of X. We replace X by G of X. 5 times the square root of G of X minus 2. Now, G of X itself equals X squared plus 4X plus 4. This is just 5 times the square root of X squared plus 4X plus 4 minus 2. Of course, you can do the 4 minus 2, so it's probably a good idea to go ahead and simplify this. There's no doubt that 4x minus 2 is equal to 2. That 4 minus 2 is equal to 2. Okay? So that's a valid simplification. Again, you can't distribute that square root over the rest of this stuff. So you can't do a square root of X squared and get something else for the rest of everything. Okay, so you got G of F of X now. So G of X is X squared plus 4X plus 4. If X is then replaced by F of X, then we have to replace every X over here by f of x. And it's pretty easy to see that if you place all these x's by f of x, this is what happens. And I don't know why I'm rewriting it, I just wrote. And then f of x is 5 square root of x minus 2. So f of x squared would be this 5 square root of x minus 2 quantity squared. Then we have our plus 4, which hasn't been affected. Now, if we square 5 times x minus 2 squared, we get 5 squared times the square root of x minus 2 squared, because square does distribute over multiplication. It's the way x is. And 4 times 5 is 20, so we have 20 square root of x minus 2 plus 4. Now, 5 squared is 25. If you square the square root of x minus 2, you get x minus 2. Provided x is in the domain of this function, the domain of this f of x function consists only of numbers that are greater than or equal to -2, or greater than or equal to 2, because otherwise x minus 2 would be negative. You couldn't take the square root. So you got to be a little careful about that. Your text will and your materials will show you that. I honestly don't know if that very bottom of the screen is showing. Barely there. So you can see it now. Okay, then we have 20 and the square of x minus 2 plus 4. And there's more simplification we can do. We have 25x minus 50. We could add the minus 50 before. Oh, but then we'd be done. Okay. And that's just bookkeeping. Okay. The main thing I want you to see is how you form the composite. See this line? Well, I mean, your algebra should be okay for this step and this step. That's the main point of what I'm showing you right now. Okay.